Alright, now we are going to take a log expression that is in expanded form and we're going to condense it. And here are the log properties that we're going to use to condense the expression. They're the same properties that we use to expand log expressions. So if we take a look at our expression, we can see it's kind of a long one, but we look inside the brackets and just look to see what can we do first. And the first thing that I notice is on the first expression in the brackets, there's a coefficient of 2. And none of my log properties for putting terms together have anything to do with a number in the front. However, my third property tells me how I can get rid of that number in the front. Property 3 says that I can take my number in the front and take him upstairs as an exponent. And that's how I choose to start this problem. I'm going to take my 2 and put him up top. So I'm going to have 1/3. In the brackets, I'll now have the natural log of x plus 5 with an exponent of 2 minus natural log of x minus the natural log of x squared minus 4. Now I'm ready to keep going. I'm still in the brackets and I would like to put log terms together. And I can do that now. I don't have a number sitting in front of either logarithm, so I look up at my properties and see what applies. So now I take a look here at property 2. And the second one says that if I have a logarithm minus a logarithm, then I can make that the log of a fraction. So I have logarithm minus logarithm. I can work with that. I'm going to have my 1/3 in the front. I'm just dragging that along in front of the brackets. And again, logarithm minus logarithm can go together. That'll be the natural log of a fraction. The top of the fraction comes from the first logarithm. It'll be x plus 5 squared. The bottom of the fraction comes from the second logarithm. The bottom of the fraction will just simply be x. And then I still have my other log in the bracket. So I still have minus the natural log of x squared minus 4. Alright, so we've got it condensed some and we're ready to keep going. To keep going, I stay inside the brackets, and I can see that I still have logarithm minus logarithm. So I'm still going to use that second property. Logarithm minus logarithm says make a log of a fraction. So natural log of a fraction. The top of that fraction, the numerator of this new fraction, is the argument of the first log of the 2 that I'm condensing. So it's going to be a fraction itself. The numerator will be the fraction, the square of x plus 5 divided by x. The bottom of this new fraction will be the argument from the second log of the 2 that we're condensing. It's going to be the x squared minus 4. Now, I think we all know that we can't leave compound fractions in answers. And a fraction inside a fraction, that's considered a compound fraction. So, let's think of this x squared minus 4 as x squared minus 4 over 1 and get to work on that compound fraction. We know that one fraction divided by another fraction is the same thing as the numerator times reciprocal of the denominator. So we're going to multiply the top by the reciprocal of the bottom. We're going to have 1/3 times the natural log of the square of x plus 5 over x times reciprocal of the bottom is just 1 over x squared minus 4. Multiply fractions by multiplying numerators together and multiplying denominators together. And now we're going to have 1/3 times the natural log of the square of x plus 5 over x times x squared minus 4. There's no reason to distribute this x in the bottom right here. There's no reason to distribute that across the x squared minus 4. It certainly wouldn't be wrong to, but there's no real reason to do that either. And now we're almost done with our problem. The only thing left to do is to take care of this 1/3 that's sitting in front of the logarithm. We have a property that says numbers in front of logarithms get to go up top as exponents. So we can put this 1/3 and make it an exponent on the argument of the logarithm. We'll have the natural log of the square of x plus 5 divided by x times x squared minus 4. Now all of that is going to go to the 1/3 power, so I need some kind of grouping to show that it's all going to the 1/3. So I'm going to stick some brackets on there. And then I wouldn't leave my answer quite in this form. We're almost there, but we should all know that a 1/3 power is the same thing as a cube root. Remember the radical rule? There's a rule that says something to the 1 over n power, y to the 1 over n is equal to the nth root of y. So a power of 1/3 is the same thing as a cube root. We can take our log answer and finish it off by writing the natural log of the cube root of that big fraction. Natural log of the cube root of x plus 5 all squared over x times x squared minus 4. And that would be a final answer on our log problem.